Hello friends, let's discuss the next architectural principle, which is layering. We already discussed domain separation. So just to give you a recap, that we are discussing architectural principles and design principles as outlined in ISO IEC 19249. So ISO IEC 19249 formally differentiate between the architectural principles and design principles. So first we are covering architectural principles. Once it is done, then we will move on to design principles. It's also very interesting to look back and see where this discussion of principles come from and how principles take shape of a concept, and based on those concepts we define some framework, and then we define some policies around the framework, and then we use that policy for some sort of governance in information security, right? So understanding the principle is key. Just to give you a resemblance, in our real world, where we interact with our nature, and we know that there are many natural principles we have understood in terms of natural laws, right? So we have understood the law of gravitation, and in that law of gravitation we explored the principle of material interaction. So if there are two matter, they interact just because they have mass. So this is the principle. This is a natural principle, and we all experience this natural principle. Now this natural principle, when it is studied in detail, to know that how these natural principle exist in terms of how much force is being applied between two matter in proportion to its mass, then we develop a concept to explain that principle, and that concept is explained in form of certain laws, like laws of gravity or laws of motion, right? So the principles are the underlying truth, the underlying reality of the nature, and these principles, since we are human beings and we love to explore, we love to interpret, and we love to experiment things, so we develop concepts. Concepts are the mental maps we create to explain certain natural phenomena. Now these concepts, actually, when they explore, the exploration is done first and then we develop concepts, and these concepts are, when they are put in words, they are explained in terms of mathematical equations, then we come to know that these principles are actually governed by some underlying laws, and these laws, when we explore, we go in more details, right? So we have got principles, which are laws, we develop concepts, and around those concepts, on a next level, we do engineering. We use these concepts to do more experimentation, and we know that we have a spacecraft now, we have aeroplane, we have rocket missiles. So these all technologies are possible only because we have explored certain natural principles, and we have explored those principles to discover what are the laws governing those principles, and we have the conceptual understanding of it. This is very relevant to information security as well. In information security, we know that there are 6 underlying principles, right? There are 6 underlying principles. I have already explained those 6 principles, which are explained everywhere, or which are used everywhere in information security world. So those 6 principles, if we look into domain 1, which is security and risk management, and if we look into domain 2 or domain 3, security architecture and engineering, we will see that those principles are used, or the concepts of those principles are used to build some frameworks, to materialize some control points, right? I will give you one example just to explain it. So we know that there is a principle of access control, right? So access control is a principle which says that we should have some sort of restriction or some sort of filter which will establish a control point of any subject accessing any object. So that's the principle of access control. So out of the 6 principles, this access control is one of the principles. Then we have the principle of availability as well. the principle of confidentiality, integrity, authenticity, non-repudiations. So this access control is realized or is implemented on certain equipments, on certain network interface or firewall appliance, where we define rules, specific rules to allow certain subjects to access certain objects, or we define some file system or file structure where we have permissions defined for users, that which user can access which file. So if you look deep into it, so there is a principle of access control which says that access to an object has to be controlled or has to be specified specifically, and we should know it, who is accessing what. Now this principle is applied as a technology or as a technical appliance into different areas of the cyber infrastructure we have in any organization, right? I hope this abstraction of concept is clear, and you have a good understanding of it, right? Similarly, you have a principle of confidentiality, and the principle of confidentiality says that the secrecy of data has to be maintained, and only the intended user can read or write or whatever they want to do based on the permission. Now, how we achieve this principle of confidentiality? We achieve this principle of confidentiality using a technique which is called encryption, right? Or we use access control to achieve the principle of confidentiality as well. So there are different techniques, there are different methods to achieve one principle, right? Now when we have an understanding of the principles, then we know that how these principles are applied and how we develop a concept around these principles, and those concepts are used to build a framework, right? Or these principles are used to develop a set of security controls. So risk management framework is a type of framework, or privacy framework, right? So these are the frameworks and these frameworks tend to achieve a specific objective. Then we have a list of security controls like NIST 853, which define the security and privacy controls for an organization. So these documentation or these standardization come out of the concepts which explains the underlying principles. So you have principles, the underlying truth, then you have concepts which you build in your mind. Then based on the concepts, would you define frameworks, privacy framework, or the risk management framework. These are the two popular example. And then you define set of controls, and using the frameworks and controls, you define your own, tailored information security policy, right? So let's move into the current topic, which is layering. I will be explaining layering and how it relates with domain separation. So when we talk of layering, layering is essentially a hierarchy of a structure, right? So layering says, or the principle of layering says that a system which is providing a unique service has to be layered into different abstraction, and the layering will be in a way that lower abstraction provides services to the higher abstraction, and that provides services to the more higher abstraction, and you have a top abstraction and you have a bottom abstraction, right? And all the abstractions are dependent on each other to provide the ultimate service. So if you look into the definition for layering says that layering is the hierarchical structuring of a system into different levels of abstraction, with higher levels relying upon services and functions provided by lower levels, and lower levels hiding or abstracting details of the underlying implementation from higher levels, right? So if you recall your understanding of TCP/IP networking or OSI layers of network, you will see that OSI layer, where we define the communication stacks as 7 layers, is a perfect example of layering. So in OSI stack, you have got physical layer, then you have data link layer, then you have network layer, then transport layer, session, presentation and application layer, right? So these are the 7 layers, and if you look carefully, that the data link layer hides the abstraction of the physical layer, right? And this abstraction is achieved using some protocols, right? So you have got media access control or link level control, which is established on the layer, which is data link layer, and you define certain encapsulation of a payload, which is called a frame, right? A frame, it actually encapsulates the underlying electric voltage or signals or impulse, whatever you say, and that's the way data link layer actually functions, by abstracting the details of the physical layer. Similarly, the network layer abstracts the data link layer, and then a transport layer abstracts the details of the network layer. So this is the conceptual understanding you should have of layering, right? Similarly, in a software system, you have got operating system calls, and these operating system calls are used by libraries which are built upon the operating system's call. So in software system, you may encounter operating system calls upon which libraries are built, upon which we build our programs, and within the operating system, higher level functions such as file system functions are built upon lower level functions such as block or disk IO information. So you have a storage arrays where you have lower level program designed or programmed in a way to actually go to a specific sector of a disk and read the data. Then you have file system. A file system gives you the idea of the partitioning the storage and putting a basic access level control so that who can access which part of the file. Then you have a higher level program which uses this file system for some end user. So you have got some software which has some specific permission to access certain file system to execute its program. So this is another level of another example of understanding layering, right? Normally in a web application, you may have seen in many places you have got any application which is internet facing, it is behind a load balancer. I think I have explained this concept in my last video. You can refer my last video for a good explanation of it. So you have got a load balancer which acts as a front end of all the user traffic which hits to the application. Then you have user interface, then you have business logic, and then you have data access, and then you have database, right? So these are the different tiers you can have, and these tiers represent different layers, and these layers are having a specific purpose, and they can be tuned with a specific security policy in a way that the whole stack is secured, right? So the purpose of layering is to first create the ability to impose specific security policies at each layer, and second, simplify functionality so that the correctness of its operation is more easily validated, right? So the second principle which says that simplify functionality for and easy validation. This, if you recall, this is one of the property of Salzer and Schroeder's design principle, which we have already discussed, right? So most of the design principle in ISO IEC 19249, you will find a reference into the old classical architectural and design principle, which was led by Salzer and Schroeder's. So from a security perspective, higher level always have the same or less privilege than a lower level. This is one of the principle. Within this principle, we have to be mindful of that higher level always have the same or less privilege than the lower level. There will never be a case that you have got higher level, higher layering, which is having more privilege than lower layering. In that case, you will be developing covert channel, or you will be developing unnecessary paths which can be bypassed by an attacker. So if layering to provide security control, it must not be possible for a higher level to bypass an intermediate level. For example, if a program is able to bypass the file system layer and issue direct block level IO request to the underlying disk storage devices, then the security policies enforced by the file system layer will be compromised, right? So because the file permission is something which is provided by the file system, right? The program, like this FAT32 or NTFS program, right? There on top of that you build your permissions and everything. So if that is compromised and an application program can directly reference a storage location, that's a problem. So when it comes to the relation between domain and layers, you may think of the mathematical function, right, for an independent variable and dependent variable. So a domain can have multiple layer, right, but it is highly unlikely that one layer will be having multiple domains, right? So you may have a domain which is a production domain, and that domain may have two layers. One is the application logic layer and one is the database layer, right? So for a production domain, production zone, it is possible to have an application layer and a database layer, right? Or if when it comes to look into the services provided by a web application in a holistic way, I have already explained that it can be viewed as first a load balancer based application presentation in DMZ, and then that can in turn can talk to a web server which is in some production segment, and then an application logic which is in a different VLAN or VRF in the production segment, separated by a firewall, and that business logic server can talk to a database server which is again behind a different firewall, and this database access can further be controlled by a specific content security policies on the web server or on the application server. So this is the way we can have a relationship between domains and layers. As I already said, in one domain you can have multiple layers, but it is highly unlikely to imagine a situation where you have one layer having multiple domains. A layer can connect to multiple domains, right? So you have got an application layer where you have an application server. It may have a connection to production domain and connection to a management domain, right? The server itself can have different connection, but these connection cannot be made possible to communicate to each other. If that happens, that creates a covert channel. So that is something you should be mindful of. So another example where layering is used in the real world is a file system, right? So in a file system, the lowest layer, access to the raw disk, provides only basic protection to the disk sectors. The next layer might be the virtual or logical partitioning of the disk, right? You have C drive, D drive in the system, or disk 0, disk 1, that kind of logical representation of the disk. Its security assurance would be access to those disk partition or in the form of certain data integrity or high availability function. A still higher layer would be the file systems, as users browse the data employing advanced access control features, right? So in a file system, basically you define all the access permission and everything. So you can't have an application which can directly talk to the storage. It has to go through file system where you will be having a specific security control. That's all about layering. I hope this video was useful. If you really like this video, put a thumbs up. You can share my video with your fellow friends who are preparing for CISSP, and subscribe and press the bell icon so that you don't miss any next update. Thanks for watching.